All right, today we're going to pull back the curtain on one of the most important but kind of unsung heroes of the digital world. I'm talking about the engine that powers everything from your photo filters to complex financial models and, yes, cutting-edge AI. It's called NumPy. And to really get why it's such a big deal, we have to start with how machines actually see the world.
So, let's just start with a simple question. When you show an AI a photograph, say of a cat, how does it actually see it? I mean, it doesn't see fur or whiskers or cute little ears, right?
It sees numbers. That's it. Millions and millions of them. Every single number just represents the color and the brightness of one tiny pixel. And this is the fundamental truth for pretty much all of modern computing. To an AI, your photos, your videos, even the words that I'm saying right now, it's all just a massive, massive collection of numbers.
And that really brings us to the first big idea. For computers to understand and interact with our world, they first have to translate it to the only language they really get, the language of numbers.
Just think about it for a second. A self-driving car is processing tons of sensor data. A weather forecast is just crunching atmospheric data. A new drug might be discovered by simulating molecular data. All of this, every bit of it, requires doing math on these enormous sets of numbers, and doing it at lightning speed. And that, right there, is a huge computational challenge.
Now, you might be thinking, hey, Python is the language of data science, so it must be amazing at this. And you'd be about half right. Python is a fantastic, super flexible language, but its built-in tool for handling lists of things, well, it has a serious speed problem when it comes to big data math.
So on the one hand, you have standard Python lists. They're easy to use, they're flexible, but they are painfully slow for math because you have to loop through every single item, one by one by one. But on the other hand, AI and big data have completely different demands. You need extreme speed. You need to apply one operation to millions of things all at once. There's this massive gap between what Python offers out of the box and what the modern world actually needs.
And this is where our hero finally enters the scene. To solve this exact problem, a specialized library was created, designed from the ground up for just one thing: super high-performance numerical computing. And its name is NumPy.
NumPy, which is short for numerical Python, gives Python a brand new, incredibly powerful data type. It's called an n-dimensional array, or ND array for short. Just think of it like a list on steroids. It's a super efficient grid of values that are all the same type, all packed together in one continuous block of your computer's memory. And that structure, right there, is the secret to its unbelievable speed.
But hey, don't just take my word for it. Let's actually see the difference in action. We're going to do a really simple task. Take a list with 10 million numbers in it, and just add 5 to every single one. First up, the standard Python list, which has to do it the old-fashioned way, with a loop.
Okay, so using a standard Python list, the operation takes 311 milliseconds. I mean, that seems pretty fast, right? It's less than half a second. Now, let's see how long the exact same job takes with a NumPy array.
58 microseconds. Not milliseconds, microseconds. Just let that sink in for a moment.
Yeah, that is not a typo. NumPy is over 5,000 times faster. The reason for this magic is a concept called vectorization. Basically, instead of looping through items one by one in Python, NumPy just hands the entire array over to super-optimized, pre-compiled code that can blast through the entire operation on all the items at once. This isn't just an improvement, it's the superpower that makes modern AI even possible. But wait, there's more. NumPy's advantages go way beyond just raw speed. It fundamentally changes what you can do with your data. It unlocks these new abilities that are either really clumsy or just straight up impossible with regular Python lists.
Let's check out two of these superpowers. First, the ability to instantly update entire sections of your data. And second, the power to filter your data just by asking simple, logical questions. So first up, let's try to update what's called a slice of data. Let's say we have this list of numbers, and we want to change the third, fourth, and fifth numbers all to the value 100. It feels like something you should be able to do, right? But with a standard Python list, you try it and bam, error. It just flat out doesn't work that way.
Now check out NumPy's solution. You use the exact same totally intuitive command, and it just works, instantly. And this is a much bigger deal than it looks. Think about Photoshop for a second. When you draw a big black square on a photo, you are doing exactly this. You're updating a slice of all the pixel data. This is absolutely essential for data manipulation.
Okay, the second superpower is called Boolean indexing.
And this is just an incredibly cool way to filter your data. Instead of writing some complicated loop, you can just ask your data a question directly. Like, hey NumPy, give me all the values in this array that are greater than 50. And boom, NumPy instantly hands you back only those values. It's powerful, it's easy to read, and it is blazingly fast.
So when you put it all together, this insane speed, this power, and this elegant way of working with data, you realize this isn't just some neat programming trick. It is the literal foundation that our entire modern technological world is built on. Seriously, without this kind of speed, a self-driving car couldn't process sensor data fast enough to react to a person stepping into the road. Your phone wouldn't be able to apply a photo filter in real time. These aren't just little conveniences, they are fundamental requirements for the tech to even work.
And the applications are literally everywhere. Every time you use a filter on a photo, that's NumPy under the hood, manipulating pixel arrays. Those massive neural networks behind generative AI, they're basically just giant, incredibly complex NumPy operations. Scientists use it to analyze data from telescopes, and engineers use it to simulate quantum computers. The list just goes on and on.
So while you might hear more about the flashy libraries like Pandas for data analysis or Tensor for AI, it is so important to remember what's lying underneath it all. NumPy is the bedrock. It's this silent, ultra-fast engine doing all the heavy lifting, making that entire data science ecosystem possible in the first place.
And that kind of leaves us with a final thought. We live in a world that is just overflowing with data. By giving us the power to process these huge numerical representations of our world almost instantly, tools like NumPy don't just make our computers faster, they completely change the kinds of problems we can even dare to solve. What's next?